Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA June 2020, paper 3, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Welcome along to another past paper walkthrough. Today we're going to have a look at June 2020 paper 3 Foundation Tier from AQA. It's actually listed on their website as November 2020 for some reason, so you can either download it from there or there's a link below in the description. Let's get into it. Question 1. What is 6.2819 to 2 decimal places? Circle your answer. Okay. So I've got 6.2819, then the first decimal place is the first digit after the decimal point, isn't it? So there's decimal point, and the 2 is the first digit that follows it. The 8 is the next one, so that's the second decimal place. So if we want to round this to 2 decimal places, then we need to round it off after that 8. Now before we just write down the answer as 6.28, we do need to just check this digit on the end, the first digit after where we cut off, and we need to check that that is 5 or more, in which case we raise the score, or 4 or less, in which case we let it rest. In this case it's 4 or less, it's 1, so we're just going to round down, we say, so it's just stays the same as 6.28. If that was a 5 or a 6 or a 7 in that red box, then I would need to raise it to 6.29, but I don't, so it is that one there. Question 2, 50% of a number is 40. Well, 50%, that's a half, isn't it? So half of a number is 40, so the whole number must be twice that, must be 80, mustn't it? So 50% over 80 is 40, okay? Question 3, circle the correct statement. I've got 0.07 on one side and 0.7 on the other. I need to determine the correct inequality or equation that goes in the middle. Well, they're clearly not equal, are they? They're not the same as each other, so it's not that one. Now, 0.07 is the smaller one, isn't it? That's kind of 7/100ths, whereas 0.7, that is 7/10, which is much bigger. Okay, so this first one says that 0.07, the small thing, is greater than or equal to 0.7. That is not true. We already ruled out the second one. The third one, that seems correct to me. 0.07 is smaller than 0.7, and the last one, 0.07, is definitely not bigger than 0.7. So it's that one there. Question 4, shapes A, B, C, and D are on the square grid. Yeah, you can see them all there. Which 2 shapes are congruent? Circle your answer. Now, congruent is a special mathematical word. It means exactly the same shape and the same size. Okay. Now, none of these shapes immediately look identical, but congruent could be a mirror image of the shape, or it could be a rotation of the shape. Okay. So now I think it's A and C that go together. I don't know if you noticed with B and D, they at first glance they look similar, but the two chunks here this is like 2 along, whereas that's only 1 in, isn't it? So they're not quite the same, those. So it's definitely A and C, I think. A and C. Question 5. Here are 3 number cards, 8, 5, and 3. Use all 3 cards to make the answer to this calculation a multiple of 10. Okay, well, if it's a multiple of 10, it must have like a 0 on the end, mustn't it? Okay, so we're looking for 2 numbers that multiply together to give you a 0 on the end. Well, it can't be the 3. Could be the 5 and the 8, because 8 times 5 is 40, isn't it? And 3 times 5 is 15, 3 times 8 is 24. So I think it's going to be like the 8 and the 5 in these 2 positions here and here. Now, I don't know which way round they go yet, but I do know that 3 then must go at the start. Okay, so I could either do like 38 times 5. 38 times 5, that would work. Okay, 38 times 5, that would be 380 divided by 2. That would be 190, wouldn't it? So that would work. And actually, you could have it the other way around as well. You could have the 5 and the 8 this way around. 35 times 8. What's that? 70 times 4, 140, 280. So that one works as well. Okay, so as long as you've got the 3 at the beginning, then the 5 and 8 can go in either order. Use all 3 cards to make the answer to this calculation a single digit number. So it's got to be less than 10, isn't it? So this is going to be less than 10. Okay, so well, if it has to be less than 10, then the multiplying at the front needs to be quite small, so we can take a number away and get it less than 10. I think we're going to have to take the bigger one away from the smaller 2 multiplied together. Does that work? So 5 times 3 is 15. Take away the 8. Yep, that seems to work. Okay, I don't think any other combination will work. 3 8s are 24. If I take away the 5, I'm going to get 19, so that's going to be too big. Okay, yeah, I think that's the only answer. Good job. Right, let's move on. 5C, use all 3 cards to make this a correct calculation. Well, we've got 8, 5, and 3. And we've got 2 numbers added together as a numerator and 2 numbers added together as denominator. And we're dividing those numbers and getting 1. Okay, so if we're dividing 2 numbers and get 1, then they have to be the same number, don't they? Okay, so we need to make the top and bottom number the same. So how about we put the 5 up here, so then 6 plus 5, that's equal to 11. And if we add the 8 and the 3 below, then that's going to be like 11 divided by 11, which is 1. Okay, so that seems to work. So the 5 goes with 6, and then we've got the 8 and 3 added together. Question 6. Greg wants to buy a games console that costs £267.50. He already has £125. He will save £7.50 each week. In how many weeks will he have saved enough? Okay, well, I think we can start off by working out how much he still needs to save. So if we look at left to save, that's going to be equal to how much it is, £267.50, minus the amount he's already saved, 125. So 267.5 minus 125, that comes out to be £142.50. 142.50. So that's what he's got left to save. So then the number of weeks it's going to take him to do that then is the amount of money that he's got saved divided by the amount he's saving each week. Okay, so if I do that, 142 divided by 7.5, that comes out to be 19. So it's going to take him a while. That's going to be 19 weeks then, isn't it? Okay, that's the answer, 19 weeks. Question 7, match the algebra to the correct description. 1 has been done for you. So I've got 4x less than 12, and that is linked to the inequality down there. That looks right. So 6x equals 24. You can see it's got an equal sign in it this time. It's not an equality, it is an equation. So let's link those up. That's going to be an equation. And then I've got 5x plus 3, and I've got a term and an expression left. Now, one of those, like the 5x by itself, that would be a term. But when you've got more than one thing added together, then that is an expression. Okay, so those two go together. Oops. Do it properly. Okay. Done. Question 8. A team of 2 players is picked from these people. You've got 2 females, Amy and Laura, and you've got 3 males, Eric, Rob, and Tim. Okay, the team must have 1 female player and 1 male player. Complete the list to show all of the possible teams. So the first one's been done for us, isn't it? I've got A and E here, which represents Amy and Eric up here. Okay. Now with these sorts of questions, it's best to be systematic with your listing. Otherwise, you tend to miss one out. So what I tend to do is I will keep one the same, and I will change the other one. And I'll run through all the others. So I'm going to keep Amy, and then switch round the male players. So the next male player is Rob, and then again keep Amy, and then the next male player is Tim. Okay, and then we're going to switch, because I've done like Amy with all 3 of the possible males. We can then switch to Laura and run through the 3 selections again for males. So Laura, Eric, Laura, Rob, and Laura, Tim. So they're all the teams, aren't there? There's 6 different teams altogether it's possible to have. Question 9. 500 people started a race. 280 were men and the rest were women. 80% of the men finished the race. 30 women did not finish the race. Complete the frequency tree. Okay, so we're told there are 500 people starting the race, and that's the 500 people that we've got to start with. Now the next thing it's going to do is it branches into male and female, men and women here. And we're told that 280 were men and the rest were women. So of those 500, we know that 280 there were men. So how many women does that leave? If I take 500 and I subtract 280, it leaves 220, doesn't it? So there must be 220 women. Okay. Now, at this point, we've got 2 different things to do. We've got to do the male finished, didn't finish, and we've got to do the female didn't finish and finish. Okay. Now we're told that 80% of the men finished the race. Okay, so what's 80% of 280? Okay, well, doing my little triangle. Final, original, multiplier. Final is what we're looking for. Original is what we're starting with. It's 280. Multiplier. 80% as a multiplier is 0.8, isn't it? Okay, so cover up the thing you want, final. Okay, so it tells me that final equals original times multiplier. Okay, so that is original is 280 times a multiplier of 0.8. What does that come to then? 280 times 0.8, that is 224. Okay, so we were told that 80% of the men finished the race, so 224 go in here. So presumably the rest didn't finish the race, isn't it? So I got 280 who did finish, less than 224. What's that then? That leaves me with 56. Okay, so that's got to be 56 in that box there. And then finally, what happened with the women? 30 women did not finish the race, so I know that they did not finish down there. Must be 30. So then this box up here then must add together to give me 220 then, because there are 220 women altogether. So then that one must be 220 minus 30. It's going to be 190 in there. Okay, so with these, just be systematic. Go through a tier at a time, you'll get there, and they're not so hard, these ones. Question 10, put these three distances in order of size, from the shortest to the longest. Okay, right, so notice first off we've got different units. These two are in kilometers, but this one is in meters. I think what I'm going to do, well, seeing we've got 2 in kilometers and 1 in meters, I think I might just convert the meters one into kilometers. And also notice we've got fractions and we've got decimals, so we need to kind of even those out and just make them all decimals. So I'm going to make them decimalized kilometer distances. Okay, which means I've got to do nothing with the first one. It's already a decimalized kilometer. Now the second one, 1600 meters. Now there are 1000 meters in a kilometer. So dividing that by 1000, I'm going to get 1.6. So that is 1.6 kilometers. And then finally, 3/4 as a decimal. This is already in kilometers, but 3/4 is 0. Well, it's 1. No, it's not, 3/4 is 0.75, isn't it? So 1 3/4 is 1.75. If you didn't already know that, I just kind of remember that one, but if you didn't, you can just type the top every fraction into your calculator and it will tell you. So 1 3/4. If I press equals and then symbolic to decimal, I've got 1.75. Okay, so now I've got them all in kilometers and all decimals. It's really easy to see that. This one is the smallest, so that's the smallest. And then the next biggest is this one, second, and this is my third one. So I'm going to write them down. I'm going to write them down back in the form they were to begin with. So 1600 meters, and then 1 3/4 kilometers, and then the longest distance is 1.8 kilometers. Okay. Question 11. AB is a straight line. Work out the size of angle X. Okay, now angles on a straight line add up to 180 degrees. So these three angles, this one, and our unknown X, all lie in a straight line. So they should, if I add them all together, so the 1.3 plus the 49 plus the X, that should give me a straight line, which is 180 degrees. Okay, now these two added together, 103 plus 49, that comes to 152, doesn't it? So 152 and X give me 180. So then taking 152 away from both sides, that is going to leave me with, they're going to cancel out, going to leave me with X on the left, and 180 minus 152, and that be 28. So my answer is 28 degrees. Question 12. Some players were asked the shirt colour of their football team. Each answer was either white, blue, red or green. A pie chart is drawn to represent the answers. 2 of the sectors are shown. The number who answered red is 3 times the number who answered green. Complete the pie chart. Let's just quickly start by tabulating what we've been given. So colours and angles. So we've been given white already. That's 75 degrees. We've got blue, which is 165. Now we want to know red and green, don't we? Okay. Now red and green added together is going to give me my whole circle. So it's going to add up to 360 degrees, isn't it, altogether? Okay. Now we're told that the number who answered red is 3 times the number who answered green. Okay, so this one here is 3 times bigger than this one. Okay, now I don't know what they are, so why don't I just call this one X for now. So if green is X, then red is 3 times bigger. That must be 3X. Okay, so I've got my 2 angles, 75 and 165, and I've got my 3X and I've got my X, and they should add up to 360 degrees, shouldn't they? Okay, I think I went off the page a little bit there. Let me just budge this over a little bit. Okay, so they add up to 360, sorry. Now, these two angles at the beginning, 75 and 165 together, that makes 172.40, doesn't it? So I've got 240, and 3x and x, these are like terms, aren't they? So I can add these together. So 3x and x make 4x. Okay, and then similar to the last question, I'm going to take 240 away from both sides. Okay, so that's going to leave me this time 4x is equal to 360 take away 240, that's 120. Okay, so 4x is 120. If we divide that by 4 then, both sides, it's going to tell me that x is equal to 125 by 4 is 30 degrees. Okay, so that one there must be 30, and this one here then, that must be 3 lots of 30. That's going to have to be 90 degrees. Okay, so we just need to draw our right angle in. Probably the easiest way is just to draw a right angle here. Might want to do it with a protractor. Okay, and that was red, wasn't it? And then the other one was green. You might want to double check your angle here is 30. Okay, should be good. That's it. Question 12b. There are 600 players altogether. How many players answered white? Now I know out of a total of 360 degrees, then white, so this was total, wasn't it? So total to white, if I do it as a ratio, so then out of my total of 360 degrees, 75 degrees was white. Okay, so then what I want to know is if I change this to 600, what would the number be here? Okay, now the easiest way to do this is what we call the unitary method, going via 1. So don't know what that number is there. So what we do is we take our 360, we divide it by 360, and then we times it by 600, and then we're going to get 600 out of it. But if we do that to this side, I have to do it to this side as well. So 75 divided by 360 and then times by 600, then we can work out what the answer is. Okay, so if we do it on the calculator, 75 divided by 360, I'm not really interested in what that answer is because I'm just going to times it by 600 straight away. That comes out to be 125. Okay, so that means that there were 125 players who answered white. Question 13. Millie has an equal number of 20p coins and 50p coins. The value of her 20p coins is £2.80. Work out the total value of her 20p and her 50p coins. Okay, so if the value of her 20p coins is 280, then the number of 20p coins is going to be £2.80 divided by 20p. Then how many 20p's go into £2.80? You can probably do that in your head. 5 go into £1, so 10 go into £2, and 4 go into 80. So that's 14 altogether. Okay, so I got 14 20p coins. You can do it on a calculator as well. 2.8 divided by 0.2 should give you 14. So now I know I've got 14 coins. We're told that they're equal number of 20 and 50p coins, so there must be 14 50p coins. So the value of 50p's is going to be the 14 lots of 50p, which is £7, isn't it? Okay, so work out the total value of her 20p and 50p coins. So then the total is going to be the £7 plus the £2.80, isn't it? Which comes to £9.80. £9.80. Question 14. Here are ticket prices for a theme park. Single tickets for adults are £48, child is 26, and there are some special offer tickets where you can get 1 adult and 2 children tickets for £82 and 2 adult and 2 children tickets for £120. Now Freya buys tickets for 3 adults and 4 children. She pays the cheapest possible total cost. How much does she have? Does she save compared to buying all single tickets? Okay, so all single. We're gonna have to work out the various cases, then, aren't we? So all single would be, well, that's going to be 3 adults at £48 plus 4 children at £26. What does that come out to be? So 3 lots of 48 plus 4 lots of 26. Blimey, 248 quid. That's why Mummy never takes you to Fort Park. £248. Okay, and then, so what is it if you pick this one? So if you pick the 1 adult and 2 children combo, can we do that? Oh no, so if we do, we can do that one and that one together, can't we? So we can, because if I get the 1 adult and 2 children one for £82 and a 2 adult and 2 children for £120, that is a total of 3 adults and 4 children, which is what I've got, isn't it? Okay, so those two combinations is £82 plus £120, so that comes to £202. I'm just wondering if there are any other ways of doing it. You could buy one of those and then, is it worth, well, I could buy 2 of those, I suppose, couldn't we? If I buy 2 of those, I'll get 2 adults and 4 children, and I could add on an extra adult ticket. Okay, so it could be 2 lots of 82 plus the 48. What's that? Just going to double check that doesn't come out to be any cheaper than doing it the other way. 2 lots of 82 plus 48 comes out to be 212. No, that doesn't. Okay, so that didn't come out cheaper. So the cheapest way is doing those 2 deals together. Okay, and now how much do you save? Saving is going to be 248 minus 202 then, isn't it? Okay, so that comes to £46 saved. Okay, still, it's a shed load of money. 14b, Leroy buys 5 single adult tickets. He uses a voucher that reduces the price of the tickets by a quarter. In total, how much does he pay? Okay, so if you remember, each adult ticket was £48. So total cost of the 5 tickets is going to be 5 lots of 48, which is 10 48s of 480 divided by 2 is 240, isn't it? So that comes to £240. Less the voucher. It's a quarter off. Now I could do this. I could do 3/4. I could work out what a quarter is and subtract it, or I could just work out 3/4 of 240. I'm going to do it that way because it's slightly quicker. So 3/4 of 240, that comes to 180. Okay, so 5 adult tickets for 180 quid. Okay, that seems like a better deal. Question 15, n is negative, circle the expression that is positive. Okay, now it looks like when I printed this it all went a bit weird. That should read n squared, that should read n cubed, and that should read 1 over n. Okay, if it wasn't clear, let me get rid of these poorly drawn ones. Okay, so they're the 4 choices that we've got. Okay, now I think the easiest way to do that is just let's give n a value. Let's say n is equal to a negative number. Let's say -2. Okay, it doesn't really matter which one you pick. And let's see what happens then when we do these expressions. Then if we sub in -2 into each of these things, what happens? Now with the first one, if I've got n -2, that's going to be -2 subtract 1 then, isn't it? -2 subtract -1, so -2 subtract 1, that's -3. So that one stays negative. N started off negative, it stays negative after when we take 1 away from it. Okay, now if I've got n squared, that's going to be -2 times -2 times by itself, isn't it? Now negative times negative is positive, and 2 times 2 is 4, so that's +4. Okay, so that one is positive. So I think that one is the answer. But let's just double check the other two. So the next one, -2 times -2 times -2. Well, we just saw -2 times -2 is 4. If I times it by another -2, that's going to take me back negative again. It's going to be -8, isn't it? Okay, and then finally 1 over n, 1 over -2 then. Well, that would just be a -1/2. Okay, so you can see that this one is negative, this one is negative, this one is negative. The only one that is positive is this one. Okay, I went a bit off the page. How about that? Can you see it now? Good stuff. Question 16. Here is a formula: y equals 3.6x. Draw the graph of y equals 3.6x for values of x between 0 and 20. Now you can see on my main scale at the bottom I've got 5, 10, 15 and 20 and 0. Okay, so I'm going to create a table of values for x and y using those values at the bottom. So 0, 5, 10, 15 and 20. Now I could sub each one of these into the equation and get the answer. I could just use the thing on the calculator. Don't know if you know about this one, but if you put it in menu and then put it in table mode, okay, then you put your function in this case y equals 3.6x. so it's got the symbol f of x here. It's different notation, but you just type in the bit after the equal sign. So 3.6. Now the x you can usually get with the alpha key and tap it in. Okay. Now mine's asking for g of x, but we're only using one function in this one, so just skip over that one, just press equals again. Now the start number is going to be this number down here, 0, and the end number is going to be this number up here, 20. Now the step, what we're going up is what we're going up in. If you think from there to there, we're going up in 5s, aren't we? So we're going up in steps of 5, and if I press enter now, I'm going to get a table with all my values in. So you see in the first column it says x, and I've got 0, 5, 10, 15 and 20 down there, and in my f of x column I've got my y values then. So when x is 0, y is 0. When x is 5, y is 18. When x is 10, y is 36. When x is 15, y is 54. And finally, when x is 20, y is 72. Okay, now once I've got all those on, I can then plot those points on the graph. Just get rid of all this malarkey I wrote here. So then I've got a point at 0, 0, then 1 point there. Next one at 5, 18. Now notice that between like 0 and 10 and between 10 and 15 I've got 1, 2, 3, 4, 5 little squares. Okay, so each one of those squares is going to have to be 2. So it's counting up in 10, 12, 14, 16, 18, 20. So 18 is going to be one little square down from 20, isn't it? Okay, so when I'm drawing my 5, 18, I'm going to plot my point there. So it goes through that square there. Okay, next one, 10, 36. Similarly, 30, 32, 34, 36. I'm going to count up 3 little squares to get up to 36. 15 goes with 54. So 50, 52, 54. And 20 goes with 72. 20 goes with 70, 72. Okay, now this is the equation of a straight line. It's in the form y equals mx plus c. The plus c is plus 0 in this case. That's my plus c. So we're expecting it to be a straight line. It is a straight line. Okay, so just double check. Should be a straight line. You should always think about, well, what sort of graph am I expecting when you plot these, because you're less likely to make mistakes then. Okay, join them up with a straight line. Tum-ti-tum, there we go. Part B says in the formula y equals 3.6x, then y is the speed in kilometers per hour, x is the speed in meters per second. So convert kilometers per hour, 50 kilometers per hour into meters per second. Okay, so kilometers per hour, that is this one, isn't it? So basically the y value then is going to be 50. Okay, and we want meters per second, which is the x value. Okay, so when we're subbing this in, I'm going to sub these numbers in. So 50 is equal to 3.6x, then if I divide both sides by 3.6, then I'm going to get x by itself then, aren't I? So what is 50 divided by 3.6? 50 divided by 3.6, that comes out to be 13.888 reoccurring. Now the question says give it to the nearest whole number. So I'm going to round that one off to the nearest whole number, which is going to be equal to 14. Okay. Now you could go and look it up from the graph, I suppose. You could scroll back to the graph. You could read across from 50. If you don't like doing algebra, you could do it this way instead. You could read across to the graph. When you hit the graph, change direction. And you should see that that's also pointing to 14. So you could just use a graph to do it that way. Either method is acceptable. It doesn't say you have to do it one way or the other. You just need to come up with the answer 14. Part C says convert 30 meters per second into miles per hour. Okay, so if I'm starting with meters per second and that is 30, and I want to go into kilometers per hour, I'm going to change one and then the other. So there are 1,000 meters in a kilometer. Okay, so if I want to go to kilometers per second, I'm going to have to divide that 30 by 1,000. So that is going to be 0.03, isn't it? Let me just double check that. 30 divided by 1,000, 0.03. Yeah, so that 0.03 kilometers per second. Now there are 60 seconds is 1 minute. So if I multiply kilometers per second by 60, so this was divided by 1,000, and now I'm going to times by 60 to get kilometers per minute. So 0.03 times 60, that gives me 1.8 kilometers per minute. And again, if I times that by 60, because there are 60 minutes in 1 hour, then I can convert that to kilometers per hour by multiplying by 60. So 1.8 times 60, that gives me 108. Okay, so 30 meters per second is the same thing as 108 miles per hour. So pretty fast. Question 17. A record was kept of the number of days that 25 students were absent one term. The chart represents the results. Part A says work out the mean number of days absent. Now, this is quite a tricky question. I think what we're going to do first is we're going to make a table, a frequency table. Days absent and frequency. Okay. So number of days absent was either 1, 2, 3, 4, or 5. I just got them from the bottom line there. There was 0 as well, but no one was absent 0 days. And then frequency is going to be the height of the bar then, isn't it? So the first one, one lot, that's got a height of 5. So that means that 5 students were absent for 1 day. For 2 days absence, that's 6 students. Third was 3 days absent was 8. 4 days absent was 2, and 5 days absent was 4. Let's just double check that adds up to 25. 5, 6 is 11, and 8 is 19, 21, 25. Yes, indeed, it does add up to 25. Okay, right, so we're part of the way there. Now, if we're going to work out the mean, it's going to be the number of days absent in total, all the days absent divided by the number of students, isn't it? Now, to do that, we need to go through our table again and do days times frequency. We're basically going to multiply these two columns together. Okay, so 1 times 5 is 5. 2 times 6 is 12. 3 times 18 is 24. 4 times 2 is 8. 5 times 4 is 20. What does that add up to? So I'm going to do that on my calculator, I think. So 20 plus 8 plus 24 plus 12 plus 5. That comes to 69. And then, so then the mean is going to be all the total days, 69, divided by 25. What does that come out to be? 69 divided by 25 comes out to be 2.76. So that means on average, each student was absent for 2.76 days. Okay? So that's a bit tricky, that one. You really do need to do the table, I think, and then do the multiplying. Normally you would do this on a grid like this, so giving it to you as a table like that was a bit tricksy. 17b says one of the students is chosen at random. Work out the probability that the student was absent for less than 4 days. Okay, well, probability is equal to successful outcomes divided by total outcomes. Now the total outcomes is like all the kids that you can pick from. So there are 25 students altogether. So the total outcomes is 25. The 25 different students to pick from. Now the successful outcomes, success in this case is the ones that meet our criteria, and they are the students that are absent less than 4 days. Okay, so going back to our chart from earlier, so then the number of students who were absent for less than 4 days are going to be the students who are absent for 3 days, 2 days, or 1 day. So these 3 bars here then, isn't it? Okay, so if you remember, there were 5 students who were absent for 1 day, 6 were absent for 2 days, and 8 were absent for 3 days. 5 plus 6 plus 8, that adds up to 19. So there were 19 successful outcomes. So my probability then is going to be 19 over 25. Question 18. Bobby has these notes. He's got 3 £5 notes and he's got X £10 notes. So the total value of his notes is T. Write down a formula for T in terms of X. Okay, so the T is the total amount. So the total amount of money he's got then is going to be his 3 £5 notes, which comes to 15. So he's going to have 15. And then he's going to have 10 lots of, or X times 10, which is 10X, isn't it? So it's going to be 10X plus 15. Okay, so if he's got like 4 £10 notes, 10 times 4 is 40, plus the 15 is going to give you 55. Okay, does that make sense? So T equals 10X plus 15. Question 19. The side elevation and the plan of a cuboid are shown on the centimetre grid. So we've got the side elevation and the plan. Now the side elevation, if you've got your shape, I think it's going to be some sort of cuboid, isn't it? So if the side elevation, that's looking at the cuboid from like the left hand side, and that's what you're going to see. Now the plan is either you can think of it as a top down view, so this is a side elevation. Now the plan, you can either think it's like a bird's eye view, so looking down on the shape from above, or the other way you can think about it is a footprint. So if you squish the paper, you know, your shape into sand, what footprint would it have? So you can see it's either, you can either think of it as the footprint, or you can think of it as the top down view. It's the same shape for a cuboid, isn't it? Okay, so what we want to know is the front elevation, what it looks like from the front. Okay, now the plan then, so you've got like those 8 cubes from the top. If you're looking down from the top, you're going to see those 8 cubes, aren't you? And then the side elevation is going to be on the side here. That's going to look like you've got 3 rows of 4 on the side. So then the front is going to be a continuation of that. So I'm going to have that line that's coming along there, it's going to continue down there, and then these lines are going to continue across like that. So basically I'm going to have 2 by 3 is the front elevation. Does that look right? It's a bit of a wonky sketch, but hopefully you get the idea. Okay, so the front elevation then is going to be, it's just going to be a rectangle then, which is 2. Why are you growing in that direction? Annoying thing. Okay, so a 2 by 3 rectangle. To the nearest 1,000, there are 18,000 people at a festival. Part A says write down the minimum possible number of people at the festival. Okay, so with these kind of limits of accuracy question, I tend to write the number they give you on a scale like that. And if we're going up in thousands, I'm going to just mark down 1,000 up, which would be 19,000. The next number on the scale, and the last number on the scale, which would be 17,000. Okay, now the numbers that round to 18,000 are going to be the numbers that are halfway between those or nearer then, aren't they? Okay, so these ones are going to round to 18,000. Okay, so what is halfway between 17,000 and 18,000? It's going to be 17,500. And what is halfway between 18,000 and 19,000? It's 18,500. Okay, so write down the minimum possible number of people at the festival. It's going to be 17,500. Okay, write down the maximum number of people at the festival. Well, the kind of the boundary is at 18,500, but I suppose technically we would round that up. So let's just go one down. It'd be 18,499. Okay, this is number of people, which is a discrete value. If it was a continuous value, I would just stick with 18,500. But as it's a discrete value, and 18,500 would technically round up, I'm going to go for 18,499. Question 21, circle the equation the line parallel to y equals 5x plus 2. Okay, now remember, equations of straight lines are in the form y equals mx plus c, where m is the gradient and c is the y-intercept, isn't it? Okay, now if two lines are parallel, it's the gradient that is the same, isn't it? So two lines that are parallel are going to have the same gradient. So any line parallel to y equals 5x plus 2 is going to start off with y equals 5x. And then it could be any other number on the end. It could be a 3, it could be a 10, it could be a -5. Okay, so as long as it's got the 5 at the front, then it doesn't really matter what the second number is. It's still going to be parallel to that one up there. Okay, so which one of these equations starts with a 5? It's this one here, isn't it? Y equals 5x minus 2. Okay, all the other ones don't start with 5x, so this is the only one that matches. Y equals 5x minus 2. ABCD represents the plan of a field. There is a path across the field that starts at A, is the same distance from B, A and BC. Using ruler and compasses, show the position of the path. Okay, so make sure you keep yourself a ickle pencil that you can use with your compass. Okay, you need a special one really. Don't have like your normal long pencil, it's too long. Okay, the reason for that is when you twirl your compass around, it needs to kind of do a full 360 without bumping into your fingers. Okay, right, what we need to do is to create an angle bisector at B. So putting your compass point at B, drawing an arc that crosses BA and BC at the same distance, so without changing the aperture. And then move the compass point to the mark that you made and draw a mark in the middle. Sorry, I can't really see that very well. And then move it to the other side and draw another arc that crosses your other arc that you just drew. And then that gives you a point where you can pass through and draw your bisector. So then just grab a ruler, draw a line from B through the cross that you made, and then out the other side. That's going to be the path. Okay, now don't rub out your construction marks. The construction marks need to be there in order for you to score the marks. So if you rub them out, you'll lose marks. Leave them there. They have to be visible, otherwise you won't score both. All right, let's move on. Question 23. A is 2 times B. Circle the ratio of A to B. Now these questions always confuse the hell out of students because equations and ratios are kind of the opposite way around when you look at them. Okay, you're comparing them in a different way, so the numbers kind of jump around a bit. Let's start off with the first part. A is 2 times B. This is written pretty much as a kind of a written equation. A is 2 lots of B. A equals 2B. Okay, so it's given us an equation for A and B. A equals 2B. Okay, now what we need to know is what the ratio of A to B is. Now let's let B equal 1. Okay, so let's say B was 1, then A would be 2 lots of 1, then A would be 2. So when B is 1, A is 2. So you could say that the ratio of A to B then is 2 to 1. Okay, so it's that one there. Okay, now the reason this confuses students is that the numbers kind of dance around to the opposite sides. Now if you think about where the 2 is in the equation, I've got the 2 over here next to the B, but in my ratio of A to B, it's actually the A that ends up having the 2 and not the B. So that is why people get a bit weirded out by these. Okay, but if you think it through, it makes sense. If A is 2 and B is 1, A is 2 lots of B. A is 2 is 2 lots of 1. Kind of makes sense. All right, good. Use Pythagoras Theorem to work out the value of x. Okay, so x is the long side. It's the hypotenuse, isn't it, of the right angle triangle. You can tell because it's opposite the right angle. So this is the hypotenuse. So we call the hypotenuse C, and we can just label the other ones A and B. And then Pythagoras Theorem states that c squared, the square on the hypotenuse, equals a squared plus b squared, the sum of the squares on the other two sides. So it's going to be 32 squared plus 60 squared. So then c is, what is c then? Okay, I'm just going to type that into my calculator. So 32 squared plus 60 squared comes to 4,624. 4,624, and then so c is going to be the square root of that then, isn't it? So root answer comes to 68. Okay, just a good idea to just think about 68 here. Whenever you do one of these things, does 68 look right? Yeah, it's slightly longer than 60 and 32, isn't it? It looks okay in that triangle. 68. Chris visits a library. He cycles to the library in half an hour at a speed of 12 miles per hour. He stays at the library for 1 hour. He cycles home. The sketch represents his visit. Now this is a distance time graph, isn't it? We've got distance on the y-axis and time on the x-axis. Work out the speed in miles per hour at which Chris cycles home. Okay. Right, so average speed is equal to distance travelled divided by time taken, isn't it? So speed equals distance travelled over time taken. Okay, how much distance did he travel in his journey home? Okay, so the distance he travelled, well, it's not on the scale, is it? Okay, what we want to know is that distance there, but it isn't marked. Okay, so it's not quite as straightforward as initially it looks, because we need to find what the distance travelled is first. But we've been given the speed of his outward journey, and we can see that his outward journey took half an hour or 30 minutes. Okay, so we're going to actually do this in two goes then. So we're going to have to use speed, distance, time to find the distance travelled he originally went, and then we use that in our second calculation. So the DST triangle kind of helps us rearrange this formula. So first off, we want to know the distance. So if we cover up the thing we want to find, the d, it tells us what to do with the other two. We're going to multiply them together. So distance traveled equals speed times time. So we're told it goes at 12 miles an hour, so 12, and we know it takes him half an hour. I'm just going to write that as 0.5 for half an hour. So 12 times a half, that's 6, isn't it? So that's going to be 6 miles. Okay, so now we know it's that's 6, so we can then move on to the second calculation to work out his speed on the way home. We know that he's traveling 6 miles. How long did it take him on the way home? You can see on the way home he set off at 10:30 and came home at 11:15, which is what, 45 minutes, which as a fraction of an hour is 3/4 of an hour. So 6 divided by 3/4 or 0.75. Either way, you can just type that into your calculator and come up with the answer. 6 divided by 3/4 or 0.75 comes out to be 8. So 8 what? He travelled 8 miles. The distance was in miles and the time was in hours. So that's 8 miles per hour. These two triangles are similar. Work out the value of A. Okay. Now let's just get orientated with this triangle. I've got y here and y here, and I've got x here and x here. So it's just a good job to check that the triangles are orientated the same way so that you can match up the sides properly. These two are, they're drawn the same way around. So I can see that these two ones match up. These are matching sides, and also these are matching sides, aren't they? Okay. What we're going to do is we're going to use the matching sides that we know to work out the scale factor from one triangle to the other, and we're going to apply that that same scale factor to the other pair where we know one and not the other. Okay, so what's the scale factor first? The scale factor, we can find that by taking our 16 and dividing it by 20. Okay, so the scale factor from one triangle to the other, 16 over 20, which my calculator tells me is 4/5. Okay, so it's got a scale factor of 4/5 or 0.8. Okay, and then we can apply that same scale factor then. If I times this by 0.8, then I'm going to get A. Okay, so then A is going to be 12 times 0.8, which apparently is 9.6. So it's going to be 9.6 centimeters. Question 27. Circle the expression that is equivalent to x minus 1 all squared. And I've got 4 options of what it might be. Okay, so when you're squaring something, you're multiplying it by itself, aren't you? So actually what we've got here is x minus 1 multiplied by x minus 1. Okay, some of you might be taught first, inside, outside, last, or 2 eyebrows, a nose and a mouth. If you do struggle with multiplying out double brackets like this, I think the easiest thing to do is to put it into a table where you write your x and minus 1 here and your x and your minus 1 here, and then you kind of work it out from there. So x times x is x squared, x times minus 1 is minus x, x times minus 1 is minus x, and minus 1 times minus 1 is positive 1. Okay, so then from there your x term is here, so your x squared term is there, so it starts off with x squared. Then your term in x is made up of these two combined, minus x, that's negative 2x, adding those together, and then we've got like a 1 on the end, so plus 1. Okay, so which one is x squared minus 2x plus 1? It is that one there, the last one. Okay, now so let's say if you struggle with these, it's a good idea to do it in this table because it kind of makes sure that you do the 4 multiplications that you need to do. Okay, gives you a bit of structure in order to do that. Right, done. Here is some information about 26 houses. A, B and C are all different numbers. That's in bold. Okay, just take care of things are in bold. And then the median number of bedrooms is 3.5. Work out the possible set of values for A, B, and C. Okay, so we want to find A, B, and C. We know quite a few things already. We know that the total number of houses is 26. We know that, which is going to tell us something about A, B, and C. We know that A, B, and C are all different, and we know that the median number of bedrooms is 3.5. Okay, so those three facts should be enough for us to work out what A, B, and C is. Okay, so let's just take each one of those facts in turn and see what it tells us. Okay, so first off, we know there are 26 houses. Okay, so that tells me if I add up the total number of houses, I'm going to get 26. So 7 plus A plus B plus C plus 8 equals 26. So 7 and 8 is 15. Take that away from 26. That leaves me with 11. So that tells me that the sum of A, B, and C is 11. Okay? So I've got an equation now linking A, B, and C. Now we're told that they're all different. Now I'm going to come back to that fact. I think that might be important later. The median number of bedrooms is 3.5. Okay? So the median lies here between these two groups. Okay, so the median is in the middle. If we've got 26 houses, then the median one is going to be 26 plus 1 over 2, or the 13.5th house. Okay, so this is 13.5th house in the middle here, isn't it? It's between these two. Okay, which means that there must have been 13 houses in this section, and there must be 13 houses in this section. Okay, so for the median to lie somewhere between the two of 3 and 4. Okay, so that tells us quite a lot. Now I know that C and 8 together make 13. So C plus 8 equals 13, which tells me that C is equal to 13. 8 from 13 is 5, isn't it? So C is 5. So this one is 5. Okay. Then if we look at the top section, I've got 7A and A. That adds up to 13. So that tells me that A plus B plus 7 is 13, which means that A plus B is 7 away from 13 is 6. Okay. Now remember, A, B, and C are all different. So A and B can't be 3 each. So either A is 2 and B is 4, or A is 1 and B is 5, or some other combination of that. Okay, so it just says work out a possible set. So I could say that if A is 2, then B would be 4, so they add up to 6. Okay, it doesn't matter. There are other combinations. It could be A is 1 and B is 5 and so on, but it just says a possible set. A possible set. Okay, so a possible set would be A is 2, B is 4, C is 5. Okay, other sets are available as long as A and B adds up to 6 and not the same. So you could have 1, 5, and 5. Oh no, you can't have 1, 5, and 5 because 5's already there. I suppose you could have 4, 2, and 5. That would be a possible set. But I think we're done. Let's move on. Advertisement break. Looking for a maths tutor to help you through your GCSE, A-level or IB exams? Then why not check out Mr. Tompkins Tutors at mr.tompkins.online/tutors. Mr. Tompkins Tutors offers personalised one-to-one quality tuition online via Teams direct to your home. Tuition is delivered by myself and a team of first-rate teachers who I've personally known and worked with for years. All have qualified teacher status in the UK and a recent full DBS disclosure, so you can be confident that you're in good hands. To find out more and request a trial lesson, simply visit the website linked below and complete the online form, and we'll be in touch with you soon. Until then, let's get back to the maths. A rectangle has length 60 centimeters and width 40 centimeters. The length decreases by 15% and the width decreases by 10%. Sue says the perimeter decreases by 25% because 15% plus 10% is 25%. Is she correct? you must show calculations to support your answer. Okay. Well, if we need to show calculations, then we best decrease our length and width by the percentages, and then add up from 2 and see if she's actually true. Okay. So let's start with the 40 centimeters. Okay, so I want to do a percentage decrease. So using my triangle FOM, stick your thumb on it. Final is what we're trying to find. Original, should we start with the length, which is 60, and the multiplier then, the length decreases by 15%. So 100% minus 15%. That's going to give me 85%, which as a multiplier would be 0.85 then, wouldn't it? Okay. So then final equals original times multiplier, which is going to be 60 times by 0.85, which is 60 times 0.85 comes out to be 51. Okay, so my new length is 51. Okay, so then this becomes 51. And I'm going to do the same thing for my width. So again, same thing, final, original, multiplier, FOM, stick a thumb on it. Okay, still finding the final. My original now is 40, my multiplier, what's that then? The width decreases by 10%. So what's 100% minus 10%? That'd be 90%, which as a multiplier is 0.9, isn't it? Okay, so then again, final equals original times multiplier, which is equal to 40 times by 0.9. What's that then? 40 times 0.9, that is 36. Okay, so our new width is 36. Okay, right, so next step, so what is my new perimeter? There are various formulas for this, so I just add all the lengths together. So length plus width times plus length plus width. I'm going around all the way around the shape. So it's going to be 51 and 36 and 51 and 36, which comes to 51 plus 36 plus 51 plus 36. That comes to 174. So that's my new perimeter. (174). What was the old perimeter? I suppose we need that as well, don't we? Old perimeter is going to be same formula, but I'm going to have 60 plus 40 plus 60 plus 40, which comes to 200. Okay, so my old perimeter was 200, my new perimeter was 174. Okay, so we want to know what the percentage decrease is from that then. Okay, so we're going to do a third percentage question here, but this time I know the final, it's now 174. I know the original, it was 200. I want the multiplier, that's the thing I don't know. Okay, so covering up the thing I don't know, M tells me that my multiplier is equal to the final divided by the original. So multiplier equals final over original. What's that then? Final is 174. Original is 200. That makes my multiplier 174 divided by 200. That's 0.87 as a decimal, which is 87% as a percentage then, isn't it? Okay, So then what is the percentage decrease? If it was 100%, it's now 87%, then it must have decreased by 13%. So it's a decrease of 13%. So is she right? No, she's not. So Sue is not correct. Okay, so there's various other ways that you could have done that, you know. You could compare all sorts of different things. So you could have worked out what 25% of 200 was and compare it with the 174 that we found. You know, so but my way is just as good as any other. So as long as you're comparing two comparable things and coming to the conclusion that Sue is wrong, then you're going to get the final mark for that. All right, let's move on. Expand and simplify 4 lots of 2x plus 3 minus 5c minus 1. Okay, so we're going to have to remove the brackets, collect like terms, and see what we've got left, basically. Right, just cover up the second bracket first. Look at the first one. Just going to have to apply, I'm going to have to multiply everything inside the bracket by 4, aren't I? So multiplying that, removing the brackets, multiplying out the first set of brackets, I'm going to get 8c plus 12. Okay? Right, now just take care on the second bracket. I've got a minus sign in front of it, so it's actually -1 multiplied by everything inside the bracket, which is going to flip the sign of everything that that's inside the bracket when we remove it. So the 5c is going to become minus 5c, and the -1 is going to become +1, because -1 times -1 is +1. Okay? Right, now once we've got everything multiplied out, we can collect like terms. I've got 2 terms in c, and I've got 2 numbers, so let's collect those together. 8c minus 5c, that is 3c, and 12 plus 1 is 13. So my answer is 3c plus 13. Question 31, and we've got 2 column vectors, and we're told that we want to work out 4c plus 3d. Okay, well, 4c plus 3d, that's going to be 4 lots of the c column vector plus 3 lots of the d column vector. Okay, so subbing in c and d, I'm going to get that. Now, when you're multiplying a column vector by a scalar like this, you times both numbers by the 4. Okay, so 4 times 4, that gives me 16, and 4 times 9 is 36. I'm going to do the same thing with the second bracket. This 3, I'm going to multiply it by both numbers in the bracket there. Okay, so I'm going to get 3 times 2 is 6, and 3 times -5 is -15. Okay. And finally, I'm going to combine my 2 vectors together. Now the way I do that is I simply add the top number with the top number, and I add the bottom number with the bottom number. Okay, so 16 plus 6, that comes to 22, and 36 plus a -15, that's 36 take away 15, that's going to be 21. So my final column vector is 22, 21. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.